Find the average value of the function f of x equals x squared minus 2x plus 3 over the interval 0 to 3. So when we hear the phrase average value of a function, we want to think integrate. So this is our formula for the average value of a function. It's a fraction. The top of the fraction is just the integral. So the integral of f of x with respect to x between the limits a and b, all divided by b minus a. In our example, the a will be 0, the b will be 3. And this will be the function that we have to integrate. So that's going to give us the integral of x squared minus 2x plus 3 with respect to x between the limits 3 and 0, all divided by 3 minus 0. And 3 take away 0 is 3, and dividing by 3 is the same thing as multiplying by a third, so we can bring the third out in front of the brackets. The integral of x squared is a third x cubed, the integral of minus 2x is minus x squared, the integral of 3 is 3x. And again, it's between the limits of 3 and 0. So we keep the third outside the brackets. We swap each of the x values for 3. Then we subtract. And then we swap each of the x values for 0. We end up getting a third times 9 minus 9 plus 9 minus 0, which will end up giving us 3. So the average value of this function over the interval 0, 3 is 3. The volume, V centimeters cubed, of a liquid in a hemispherical bowl is given by V equals a third pi times 30h squared minus h cubed, where h centimeters is the depth of the liquid. Find the average volume of liquid in the bowl as the depth increases from 0 centimeters to 4 centimeters. So when we hear the phrase average volume and we're given a function, we again want to think integrate. So we want to actually think of our average value formula. So our average value formula is the integral of f of x with respect to x between the limits b and a, all divided by b minus a. So our average volume will be the integral of the volume with respect to h between the limits 4 and 0. So we got that from the question, 4 and 0, divided by 4 minus 0. So our v function is a third pi times 30h squared minus h cubed with respect to h. We're going to integrate, and 4 minus 0 is 4. Dividing by 4 is the same thing as multiplying by a quarter, so we're bringing the quarter out in front, and then we're going to integrate. We're also going to bring a third pi out in front, because that's a constant as well. There's no h term attached. So we have a quarter times a third pi. That will give us pi over 12. And then we're going to integrate 30h squared to give us 30h squared plus 1 over 2 plus 1, which is 30h cubed over 3, which is 10h cubed. And minus h cubed, to integrate, we'll get minus h cubed plus 1 over 3 plus 1, which is minus h cubed over 4, which is minus a quarter h to the power of 4. So that should actually be a 4 there, so h to the power of 4. And again, it's going to be in between the limits of 4 and 0. So don't forget you've got your pi over 12 outside your brackets. So we swap each of those h's for brackets and input 4. Then we subtract. And then we swap each of the h's for zeros. We still have the pi over 12 in front. We get 640 minus 64 minus 0. And multiplying by pi over 12, we get 576 pi over 12, which simplifies to 48 pi centimeters cubed. So the average volume of the liquid in the bowl as the depth increases from 0 to 4 centimeters is 48 pi centimeters cubed. The speed v meters per second of a particle is given in terms of time t seconds by v equals 4 sine 3t. Part 1. Find the total distance travelled in the time from t equals 0 to t equals pi over 3. So the total distance is the area under the speed time graph. So if we were to draw this out on a graph, then the total distance would be the area underneath it. And when we want to get the area underneath the graph, we want to integrate. So the total distance is going to be the integral of v with respect to t between the limits pi over 3 and 0. So v is 4 sine 3t. So we're going to integrate between these limits. We're going to take the 4 outside because it's constant, it's not attached to the t. The integral of sine 3t is minus a third cos 3t. And now we're going to sub in our limits. We're also going to take the minus a third out in front, just to save us a bit of time. So 4 times minus a third will be minus 4 over 3. We swap the t for pi over 3. Then we have a minus, and then we swap the t for 0. So cos 3 times pi over 3 is minus 1. And cos 3 times 0 is 1. And you've got your minus in between. And minus 4 over 3 times minus 2 is positive 8 over 3 meters. So this is the total distance. So the total distance travelled in the time from t equals 0 to t equals pi over 3 of the particle. Part 2. Find the average speed of the particle over this time. Well, we use Dad's silly triangle, and it tells us that the average speed is equal to the total distance divided by the total time. So the total distance we got in part 1 to be 8 over 3. The total time is b minus a, so subtracting our limits. So it's going to be 8 over 3 divided by pi over 3 minus 0. Pi over 3 minus 0 is just pi over 3. So it's going to be 8 over 3 divided by pi over 3. We change the divide to multiply, and we flip this upside down. So 8 over 3 times 3 over pi, that gives us 24 over 3 pi, which gives us 8 pi meters per second. So the average speed of the particle over the time is 8 pi meters per second.